So we are going to talk about the next step in our factoring. So before we talk about next steps, let's talk about what we've already done. And what we've already done, we have learned how to, I'll turn this into a pen. We've already learned how to factor out the greatest common monomial. And that's what you just did in your investigation as well. So the last algebra sheet was factoring out the greatest common monomial. Same with your investigation. Today we're going to talk about two different special cases. The special cases that we're going to talk about next, and this goes on your checklist, is the difference of squares and the other special case that we're going to talk about, although not today, is the square binomial. So, and again, these are special cases. They're special. So, since it's easier to deal with the factored form, turning it into expanded form, we'll start there. All right, since there is a volleyball game and volleyball feels as though they're not getting enough attention. Harper, what is your volleyball number? 7. So we have Harper plus 7 times Harper minus 7. So right now, let's multiply this out. How do we multiply it out?
Rainbows and smiley.
Rainbows and smiley faces. We'll stick with Bronco colors. H times H is?
H squared.
H times negative 7? Minus 7H. 7 times H? We have positive 7H. And 7 times negative 7? Negative 49. So let's combine the similar terms. Do we have another H squared? No. So that just gets dropped down. So we have H squared. Negative 7H plus 7H is? 0. So these cancel out, don't they? Do I have any other plain numbers? No. So I have H squared minus 49. So that means that H plus 7 times H minus 7 is equal to H squared minus 49. Are there any questions yet? Okay. So I'm going to take this, and there we go. I'm going to take this and I'm going to shrink it, bring it over here. And then I'm going to also erase the rest of it. So let's try another problem. Let's try another problem really quickly. So let's take another problem. We're going to have Michael this time. Michael, what's your football number? 2. So we have Michael plus 2 times Michael minus 2. Now before we go ahead and expand this, what similarities do you see in Michael plus 2 times Michael minus 2 and the Harper plus 7 times Harper minus 7? What similarities do you see in these pair of binomials? Beth? Well, we changed the letter and the number, so maybe that doesn't sound like too much of a similarity. Aiden?
They're both in factored form?
They are both in factored form, absolutely, which is necessary for us to be able to expand it. Are there any other similarities you notice? Do you notice anything about the structure of the binomials? Margot?
Well, if they're going to have like the same answer, it's going to be the letter squared minus the number squared.
Ah, it's going to be the letter squared minus the number squared. I want you to hold on to that thought because that's actually where we're going. What do you notice is a similarity in the numbers?
They're the same.
What do you notice? They're not the same. They're not the same. What do you notice about the numbers in the binomials? What is the connection between this problem here and the one we just did? Kira?
Okay, so in the first one you add the number, and then in the second section you subtract the number.
Oh, so we're adding, in the first one, we're subtracting in the second, and the numbers are always opposites. What's the opposite of adding 2?
Subtracting.
Subtracting 2. What's the opposite of adding 7?
Subtracting.
Subtracting 7. So we're dealing with binomials that have the opposite second term. So if it was positive, now then it's negative in the second one. If the first one was negative, the second one will be positive. Okay. So let's again multiply this out. M times m is m times negative 2.
Negative 2m.
Negative 2m. 2 times m.
Plus 2m.
2 times negative 2. So m squared gets carried down. Negative 2m plus 2m is?
Cancel out.
Oh, they cancel out.
They do indeed.
Okay. And we have our negative 4. What do you notice? What do you notice about the answers? What is similar in the expanded form of both of these equations? Stella?
They both have negative numbers, and they're both like the same but different numbers.
Okay, this is different. Okay.
And they're both square.
And they're both squares. Margot?
Should I say what I said before?
Sure, say it again.
It's going to be the letter squared subtracted by the number squared.
So it's the letter squared subtracted by the number squared. So m times m is
M
m squared. 2 times negative 2 is negative 4. And the middle term cancels out every time. This is the special case of expanding a difference of squares. Doesn't matter what numbers or letters you put in, the middle term will always cancel out because the second term in the binomials are opposites. So let's try another one, and we'll use the special case. So let's say we have, and I'll give you some larger numbers. Let's say we have a plus 12 times a minus 12. What would be the product if you multiply these two together? Livy?
Would it be a squared minus
44.
minus 44.
144.
Because a times a is a squared. 12 times negative 12 is negative 144. And that middle term is going to cancel out.
Brilliant.
So this is a much quicker way. This only works for differences of squares because it's a special case. Let's try another one, and we'll make it slightly more difficult. And when I say slightly, I mean slightly. So let's say we have Kate. What's your volleyball number? 14. Let's go with Kate minus 14, just to make it a little different. So we have K minus 14m times K plus 14m. So how do you go about multiplying this out using our new special case, difference of squares expanding? All right, we need a boy this time, so Michael?
The whole thing.
What would you get? Yes.
K squared
Because K times K is K squared.
minus.
It's going to be subtraction.
Yeah. I didn't do this. It's 14 squared.
196.
196 m squared.
No, just
What is m times m?
Squared.
Yeah.
Holy.
And again, there's no middle term because it cancels out. And we've shown why it cancels out. We'll try one more example with multiplying, and then we'll turn it to factoring. And then we'll turn it to factoring. All right. So this time let's have Kira. What's your volleyball number? Oh, I can't put C there. What's your middle name? E, okay. C minus 13E times C plus 13E. So go ahead and multiply this out using your special case difference of squares. And it shouldn't take you too long. It should not take you too long at all.
159.
All right, Stella?
C minus 169 E squared.
So is this what you have right now?
Oh, sorry. I meant C squared.
We meant C squared. Okay. Are there any questions on how to multiply or how to expand a difference of squares?